Unfortunately, early this year, I learned about the passing of a well-known music teacher in Christchurch. He used to accompany me on the piano whenever I had a saxophone performance. He was struck by a passing train while cycling on the pedestrian area of Fendleton Road. Hearing this news made me wonder if accidents like these were common in New Zealand. After doing a bit of research, I found out that there's been around 40 accidents involving pedestrians and trains in the past 12 years. So there's definitely a problem with the current model of our level crossings. There's nothing specifically telling a pedestrian that a train is about to come. When people are walking or biking in the deep in thought or start daydreaming, their senses start to turn off. They become isolated from their surrounding environment. When people use their phones, they become even more distracted from the environment they are in. As we head towards the future, the number of personalised electronics will grow. This means the number of fatalities at rail crossings will also grow, as there will be more pedestrians that are distracted by devices. The current model of our railway crossings was developed in the 1960s and needs to be updated to suit the needs of people living in the 21st century. I've been prototyping solutions to this problem. I've used an Arduino microprocessor platform to test out my circuit. First the Uno, and then the Nano. After coming up with a functional circuit, I 3D printed a plastic model to show how my electronic system would react in a real-life situation. My system uses an AVR microprocessor, a sensor, and 8 clusters of LED lights. A sensor is placed on the barrier arm of the road crossing. Whenever a train is about to come, the barrier will come down and the sensor will detect this. When the sensor detects a train coming, 4 clusters of LEDs on the pedestrian path of each side of the crossing would flash. The circuit will be connected underground to the power source at the road barrier arm. The LED clusters will appear on the surface of the ground and will be covered by a protective layer of polycarbonate plastic. The way the lights flash in this new system would also change over time, giving pedestrians and cyclists a slightly unfamiliar environment. According to Track Safe New Zealand, the more familiar we are with our environment, the less attention we pay to it. The pattern of the flashing lights would also be changed by pedestrians and cyclists themselves through a user-friendly interface near the crossing. In the future, I plan to further develop my project. As the world moves towards the Internet of Things, I would want to create a mobile app that goes in conjunction with the system. Whenever a train is about to come, the microcontroller will give off a Bluetooth signal to all nearby devices with the app. The app would then vibrate, turn off the phone's music, or sound off an alarm. It would be extremely handy for people with visual or oral impairments.